Okay. Hello, everybody. Today, I am going to discuss with you a number of examples in order to find the optimum minimum of each of them. These examples include objective functions with one variable and with two variables also. Also, we shall discuss the cases when we have constraints with the objective function or without constraints. For this purpose, we shall use cvxpy. This is a Python-based library, and we shall use LabVIEW and Scipy. This is the first time we are talking about cvxpy. So I shall give you a short briefing about it. What is cvxpy? It is a Python-based library specifically designed to optimize convex optimization problems. It enables the users to define and solve these problems using a high-level declarative syntax. Using cvxpy, we simplify formulating the complex optimization problems by allowing the users to specify the objective function and constraints in a natural, readable, simple way. Generally, cvxpy automatically transforms the problem into a standard form, quadratic standard form, and calls a solver, and at the end unpacks the results. Comparing the cvxpy with Scipy, it is considered a higher level package and more intuitive syntax for defining optimization problems. Yes, it doesn't require manual setups or understanding of specific algorithms as it is the case with Scipy. Anyhow, if you want to know more about cvxpy, there is a lot of sites discussing cvxpy in short-term tutorials, and also you can refer to Python for deeper information about it. In order to work with cvxpy, of course, you need to install it on your computer. To do this, I recommend you to work with Anaconda organization. You go to anaconda.org, open the navigator, you will find a list of uninstalled packages. There you will find cvxpy. Then you install it. After installing it, you can begin working, you can import it and work with it. To see its position in, I myself, I downloaded cvxpy from Anaconda 3. To see where it exists, you go to the PC, C driver, users, del, and you will find now Anaconda. Go to Anaconda 3. I have Anaconda 3 in my computer. Go to packages, and there you will find the letter C, CV, CL, CO, cvxpy, the version 1.5.3, cvxpy. Here it is. As you see here also, we will need to work with cvxopt. This is another package also for optimizing using the standard form. We shall talk about it when we discuss examples related to cvxopt, but now I can tell you that you can download also at the same time cvxpy with the cvxopt. This is the idea. Okay, we continue our work. So we have downloaded the package, and now we need to import it. We need to import it. So you go and import cvxpy, and as usual, to simplify the things, you import it as CP, so as to remember it, CP. Of course, you can write any other two numbers if you wish. Now, in order to work with the example which you work with is the same example which we used in the previous lecture, x squared minus 6x plus 5. This is useful so that to compare the results and to be sure that we get the correct answer. In order to work with cvxpy, really, at the first, there are definite steps to work with. At the beginning, you import the library as we did. Then you define the variables which you are going to use, either they are 1 or 2. Then you define the constraints if they exist, and then define the objective function itself. After that, you formulate the problem, and then you look at the solution of the problem which was formulated. These are the basic steps. So how we do that with our example? So at first, we define the variables. To define the variables, as you see, it is not that difficult. You call CP, which is for cvxpy, CP dot variable, and create an object called x. This is the variable x. Now, if you need another variable y, okay, you write CP dot variable again, assigned to a variable called y. Here I printed, as you see, the letter in order to not use this line only. I can keep it, I can cancel it, it doesn't matter, it's the same thing. Yes. Oh, the most important is everywhere, if you put the hash before any line, the line does not belong to the program at all. So I put it or printed the letter hash before this instruction because just I wanted to show you that if you want to create another variable, you do that. Then you define the constraints, but here in this example, we don't have constraints, so I printed the lash. And just to remind you that this step is for the formulation or defining the constraints. Now we want to define the objective function. What do you need? You call the minimize function from Scipy. Again, Scipy is the cvxpy itself, dot minimize. Note that minimize with a capital letter here. And in this function, you pass the expression of your objective function. Our objective function, as you see, x squared minus 6x plus 5, which we used in the previous lectures. So this is assigned a variable to a variable called objective. Now we have defined our objective function. The next step is to formulate the problem. How to do that? Again, very simple. Type cp.problem, and now this problem function, you pass to it the objective function which you have already defined. So this is now assigned to a variable called problem. The last thing to work with is to unpack the solution by calling the solve function. So problem, PROB dot solve function gives you the results. Now you can print directly the result and you get the value of the function, which is the minimum value, minus 4. You remember this figure. You can also find the coordinate of the variable x where the minimum occurs. So you print x dot value, and now you will get the value of x, which is 3. These numbers are familiar to you, and you can compare them and find that the same answer which we have obtained previously when we solved the same question using pi swarms or by using Scipy or other methods of Scipy, it is the same answer. So as you see, really, it is not that difficult. And in order to make you more familiarized with these things, I shall go through other 2 examples using the Scipy. This example doesn't include any constraints. Let us try it with a constraint. So we imported Scipy as CP. I imported numpy as NP just if it will be necessary for me. In this case, it is not necessary anyhow. Now we define at first the variable. My function has only one variable x, so cp dot variable assigned to a variable x. It is known. Now I want to define the objective function. X squared minus 6x plus 5. I assigned this expression to a variable cost, which is the other name of the objective function. It is the cost function. And now I pass the objective function or the cost to the minimize as we did before. Here we did the same. We passed directly the expression to minimize. Now I passed it through the cost variable. And now I have got the objective function defined. Now we want to define the constraints which we have on the variables. X must be more or equal to 0 and less or equal to 4. Why I put 4 and why I put 0? Really, I know some information about this function. I know from the previous examples that the x value, x coordinate is equal to 3. So it must be less than 4 or equal to 4. but it cannot be higher than 4, for example. It must be equal or less than 5. It's okay. So this number is written here because I know some information about the function. This is inequality constraint, and x must be positive, equal or more than 0. They are given here as elements of a list. Now, when we will try this example with these constraints, we shall get an answer. We shall get the answer which we have got before, because 4 is more than 3 and x is positive, and this is the real coordinate information related to x, so we will get the same answer as you should be. We shall try to change the constraints and see how we will find another answer for that case. Anyhow, now let us continue. So this is with constraints. Now we have defined the constraints as a list here. And now we will formulate the problem. In the problem here, we shall include not only the objective, but the constraints also. So CP, problem, P, capital letter, objective, here it is. This is our objective function. And constraints, here are the constraints. Now we want to formulate the problem. The problem is formulated. It is equal or assigned to a variable called problem. And this problem now calls the solve, or the solver called solve function. Using this solve function, we will have the results. So again, if we print the result, we will get -4. If we print x value, we will get 3. Why we get the same values as we have in the previous example? This is because the constraints here apply to our case. Suppose instead of x, which must be less than or equal 4, I printed 1. X now must be less or equal to 1. So 3 now is not included, the value of 3, and it will be excluded. So if we run now the problem, we shall have another answer. The result now is 0. And the coordinate, which means the position of x, is equal to here, as it is here. The x value is equal to 1. And the optimum value will be 0 and will not be -4. This is another problem here. An interesting thing also I have typed to show you here regarding the equalities or non-equalities. The system here, cvxpy, accepts minus equal or plus equal, but it doesn't accept strict, more or strict less alone. It should be equal and more or equal and less. Suppose we change our case here. X is less or equal to 1. Let me type it. X is only less than 1. What we will receive? Only x is less than 1. And now let us run the program. We have got an error message. Strict inequalities are not allowed. So we must always type higher or equal or less and equal, but we cannot use only less or higher than in this case. Now, if I run it again, I will get an answer, of course. Here again, it is 1 and it is 0, 0. If I change now from 1 to 3, I shall get again the previous answer as we have done before, 3 and minus 4. So as you see, the idea is not difficult and easy to apply. So what we have done up to now, we have considered an objective function with single variable, without constraints, and with constraints. Now let us try to work with an example where we have two variables. In this case, we shall have a minimum value for the function, but also we shall have two values describing the position of the minimum, which is the value of x and the value of y, for example. Okay, why not? This is working well and we will have no problem with it. Okay, here I have written for you two notes, just briefing you also, enlightening you concerning the cvxpy, that when you get at the end the solution, the problem solve function, it returns the optimal value, which we have got before, and updates prob status. It gives you an answer to the work, describing the work, whether it is carried out successfully or there is a problem with it, and the problem value, which is the x value here. We shall see this now. The second note here, the status, which was assigned a value optimal when you run the program and get at the end status optimal. This means that we have the solving of the problem was carried out successfully. This tells us that the problem was solved successfully. This is the meaning of here, as it is given, status optimal, which is the best case. The optimal value basically 1, in this case basically it is 1 because it is given in this example 1 here, is the minimum value of the objective over all choices of variables that satisfy the constraints, if there is constraints, of course. Yes. So let us try to work with this example alone. So we first need to import the cvxpy. From cvxpy import, as you see here, asterisk, which means all methods or functions, values relative to cvxpy will be available. Okay. Now create the variables, variable 1 assigned to x variable and variable 2 assigned to y. So now we have two variables already. One of them is called x and the other one is called y. Okay. Now, concerning the function, the objective function and the constraints. The constraints, as you see here, are given as also as a list. x plus y must be equal to 1. X minus 1 is more or equal to 1. These are restrictions given to x and y, and they should be satisfied. Okay? Here are another suggestion for you, another constraints for another example. I will discuss it later on. Now we are working with these constraints. The objective function here, which we are working with, is the square of x minus y. X minus y squared. So as I told you, the objective function will be, we call the minimize function and pass there the objective function. The objective function here is square of x minus y. It gives you the objective function. Now having the objective function, we can define or formulate the problem. Problem with capital P function, and we pass there the objective function OBG, which is the objective function here, and the constraints which are here. So we have passed the objective and the constraints in the problem. They are included in the problem now, and it is assigned to a new variable called prob, shortened to prob. And now from this prob, we call the solver solve function, prob solve. Now we can print what do we need. When I ask print status, prob status, so I shall have the status is carried out successfully or not. Here it is given status optimum. So it is worked. It is done well. Prob value, the problem value is the minimum. Here it is 1. In this example, it is 1. X value, Y value, because we have two values defined. Here they are given. X value is equal to 1. Y value is equal to, of course, as you see, it is a value about 0. It is exponent to the order of minus 22. It is 0 value. So the problem is solved, and we have got the value of the optimum value, the optimum minimum value, and we have got the coordinates of the variable. This is for the function which is square of x minus y. Okay. If you try to use the minimize function and pass there the square function in another way, which is x minus y squared, as it is written here. You see it. It will not be supported. The system will not support this script here. If you want to get around this, I am writing to you here, it is not supported. To get around this, we create a variable called cost. So x minus y squared, I assign them to a variable called cost. And now I pass this cost to the minimize function. Minimize cost. Here cost is passed to the minimize function. It is called now I am defining the objective function. Having the objective function, now I pass it with the constraints to the problem and create the variable problem. And having the problem, I can solve it and get new answers, of course, not these answers. So why not? We shall get the same answers because we did not change anything. We have just only changed the way we are including the square of x minus y. Let us cancel this line by typing here the hash like this. And now the cost variable equal or as is x minus y squared. It is here. And now the objective function is the cost which is passed to the objective. Now the objective is defined. And now here in the problem, the objective is okay. The constraints are the same because we are working with the same function. And now we will solve it. We will get the same answers. We will get 1, 1, 0. If I run it, okay, here it is, 1, 1, 0. The same answer, no problem at all. Okay, I have managed also just practicing with you the things to try to work with a standard test function. It is also a convex function, which is called the sphere. Why it is a test function, and what do we mean by test function in Python? In Python library, there is a number of functions widely recognized and widely known as unique functions, and they have specific performance, and they are used very often in algorithms in order to test the algorithms which you compose. So if you have an algorithm and you run it with a test function, in advance you already know what should the answer be. So this means that you are judging that your algorithm is correctly designed and works perfectly or not. So the same here, I wanted to use the sphere function, and it is expressed as x squared plus y squared. So let me first get rid of the cost function which I have done before, which is x minus y squared, now not needed. Now I need this one, the cost function of the sphere. And now the constraints, here I want to change the constraints which are there here. I want also to cancel them and use these values, which is between -5 and 5. The constraints is x more than or equal -5, and it is more than equal and -5. Sorry, what I have done here. X is more or equal -5, and here it is less or equal, okay, or 5 is less or equal y, the same. And anyhow, if there is something wrong, I shall try it to correct it soon. But I prefer that x more or equal -5, okay, and y is also equal or both of them are higher than -5. There is no problem. There is no problem. Okay, so the constraints, we have them here, and we have here the cost function. The cost function now is passed to the objective function. Now we pass the objective functions and the constraints to create the problem, and we solve the problem. Usually, when we work with the sphere function, we have the answer that the minimum value is 0, and the value of x and the value of y are also 0. So if I run this now, hopefully that I shall get the same answer. Yes, as you see here, the status is optimal, which means that the problem is solved successfully, and the optimal value is 0, and the coordinates of x is 0, and the coordinates of y is 0. So it works well and there is no problems. I hope that this is clear for you. I really try to work slowly, and usually I am working slowly, step by step, that you can understand it if you want to repeat listening to this video. Okay, finishing with this example, we shall try. Okay, before going further, let us try to find the solution of this program by using LabVIEW. So I want to go to LabVIEW and to find the solution of this question. How I go? Here it is. So optimization in LabVIEW. Here I have a lot of problems solved for optimization purposes. This is the problem which I used, the example which I used to solve the same question by LabVIEW. LabVIEW is opening. Continue to LabVIEW. And now if I go, this is the, let me make it larger. This is the front panel, and this is the code or the block diagram. This block diagram, as you see here, contains a specific function which is used to find the minimum of our function. It is called print with derivatives 1dvi. How to work with it, how I know where it is not difficult. You can go to mathematics, to optimization, and here is the function which I need, which I'm meaning. This is the same function. If you want to know what these terminals mean, you just press the help and the show context. Now you shall have here the same function with the terminals at the input and the terminals at the output to give you information what each of them represents. If you see that this information is not sufficient to you because you are new to this and you need to know exactly what is that, you press the detailed help, and then a new page will open to you, gives you more detailed information about the inputs and the outputs. As you see, this terminal here, you created to define the accuracy which you accept for the work. I told you once before that this generally is suggested to you by the system, and this function accepts from you 3 values, 2 edge values, and 1 in between. They are used through an iterative process to find the minimum. The function which you need must be input here. This color, the pink color here, represents a string, so it is given as a string. And the outputs here, you will get the minimum value of the function, f of minimum, and you will get the minimum coordinate, the value of the coordinates where you have the minimum. Okay, so this is now clear for you, so we go out and come back to our problem here. This is also not necessary for us. We are now here. So I have created a constant which represents the tolerance accepted by me. 1 exponent of minus 6, 1 of million. The values here between 0 and 5, and I selected 1.2. Maybe you select any other value here. And then here, I want to input the string which represents the values which I need, which is the objective function. The objective function here is x squared minus 6x plus 5. So if I go back there, here is a concatenating of strings. This is a string and this is a string. All these pink values are strings and they are concatenated sequentially. So this is the x squared here. Now minus 6 multiplied by x plus 5. At the output, I get here the same expression. Here it is, I created an indicator to show it. So if I double click it, you can see that when I solve the problem, I will get this expression, which is the required expression by me. And what more I have done? Here, in this aspect, if you go to the mathematics and go to script and formulas and go to calculus, you will find a function here called differentiation. So I took this icon, differentiation. It requires an input with the objective function and requires the limits. And I can get at the output the derivative values of the output values. Here is the values at the output y, it is called y, and this is the derivative of these values, which may be necessary for you in the future. Really, I took them just for drawings. So here, the value of x as an array, it represents an input value as a time value variable. Here is the value of y. So this is a function, y as a function of x. They are bundled together as a bundle. And here I took also the same value of x, which is the horizontal value of the x. And here the derivative value as an array. And now I can compare, or I can watch the function with the derivative at each point of the function. This is the idea. So here, as you see, this is the function, which is a parabolic function, which is this function, a function of 1x, but it has a parabolic function. And this is the plot which represents the derivatives. And as you see, the derivative, well, this minimum here is the minimum at 3, as we do. And here, at this point, it is 0. So when the derivative was equal, now it is negative and negative. Now it became 0. At 0 value of the derivative, we have the minimum where x equal to 3. So when I run the program, I have got also that the minimum value, which is the x value equal to 3, and the value of the function here is minus 4. Look, here it is minus 4, as we found in the by using cvxpy. Yes. These values of x I introduced by me. I put these values as x variable, and I got accordingly the y variables and the derivatives of y. Shortly speaking, there is nothing new. We got the same answer, and as my opinion, this is not a complex function to work with. this is generally a simple approach to solve the same problem. So we finish with it now and move to discuss with you another example. Okay, we are here now. So we have solved the question using LabVIEW and using cvxpy, as you heard me, with one variable, with constraints and without constraints. When we solve it with LabVIEW, we did not solve it with constraints. I shall do that in the future with other examples. Let us continue our work here. What I want to show you also today. Yes. Okay, I shall work now with you to find the minimum of a minus sine of x or minus or inverse sine value. This is a sine function, as you see, minus sine function. Here it's minimum. We want to find its minimum. I have solved this question twice. Firstly, I solved it by using Scipy because I found that there is something interesting to show you. And then I solved it also by LabVIEW. Let us consider both solutions. So with Scipy, now I will not go in detail discussing all things. So I import the necessary libraries, import NumPy as NP, from Scipy import optimize. This is the optimize function we shall use in order to find the minimum. And NumPy is used in order to create arrays. So at first we define the objective function which we have. The name of the objective function is f, its variable is x, and we need to have minus np dot sine of x. Note here that by using Python, we need to use the sine of x through Python, through NumPy, NP. This thing is not required when you work with LabVIEW, for example. And now, if we have defined the objective function, we want to define the values of the x-axis, where x is an array. So we create an array by using NumPy, NP, the function linspace, the length of the x-axis between 0 and 5, and it will be divided into equally divided 100 values. So linspace creates an array, and this array is assigned to a variable called x. We shall work by an iterative process. So we need to define, because we need to use the find minimum function, it requires a start point. This value could be any value, which I shall show you now, just randomly selected. And now we begin working. We call the optimize function. Here it is already existing. And from this function, we call f minimum function. F minimum function requires the objective function, which is called f. Here it is. And it requires a start value, which is given as a number .75. So here, the start value I can here really write instead of .75 start. I can print start instead of this value. It is the same because the start is assigned this value. So now I will get the minimum value directly because this is a function which gives you the minimum. So I print x minimum and I will get the value, the coordinate value where the minimum occurs, and it will give me x minimum value. Here it is. X minimum is equal to 1.57. This is the answer directly without any problems. Really, I wanted to show you this example not for these things. These things are, as I hope, familiar now to you. But in order to think about these things, I want to draw the function and I want to point there the start point, and I want also to show there the minimum which is found by the algorithm. Here is the thing which I want you to think about. So first of all, if I want to draw the function, I should be here calling how? I should be here, I should import matplot library dot py plot as PLT. This is required here so that I can draw, otherwise. Now this PLT is, which is the shortened form for matplotlib. PLT, I call through it the plot function. Oh, here, import matplotlib is written here. So it is the same here or there. So no problem. It is not forgotten as I supposed. So matplot library is imported as PLT. PLT now calls the plot function. The plot function requires the X array and the function. The X array is given away X, an object X, an array, it is an array, and f of X is the function, which is Y. So X and Y, directly I get this curve, but without this point and without this point. I get only this curve. If I cancel, if I put here, for example, here, if I put, I cancel this one and I cancel this one, and I run the program now, I shall get where it is. Yes, I have got the same function as you see, but without these points, nothing there. I have drawn only or plotted only the function. So again, I introduce it to the program. And now, what is written? PLT, I call another function called scatter function. The scatter function requires the value. I want to draw only a point. The point which is only the start point as an X and the function of the start point. If this is here, for example, the value of the start point, .7, like this here, the value f of this function will be this point here. So if I want to see this point, it has coordinates, which is the start point and also f of the start point. So as you see here, the start and f of the start as a scatter plot. Now it will give me only the point which I start working with. Okay, you see that? Let us go back. Let me only cancel this one, and now I run it. I shall have that point only. As you see, only this point, which has an X value equal to 0.75 and the value from here to here is the function of x equal 0.75. The last interesting thing is, of course, to see or to put on the graph, on the plot, the value of optimum to show this value, which is here, the optimum value, which is, of course, equal to the, first of all, optimized, which is the optimized x value, and the function of this x value. So I want to get this value, which is here. From here, I want this coordinate, and the function, what does the value of the function for this value here? I will get here the minimum, the optimized, and the function of the optimized. Now, if I run the program, I shall get the complete solution. So I have the initial point, I have the optimal point, I have the function, and of course, I have got also the values which I need. The x minimum was 1.57. If I go here, this is 1, this is 2, this is 1.57, this point here, the x value, and the y value is equal to, it seems to be -1, about -1. How much it is there in the program? -1. It is -1. Current function value is -1. Okay, we have finished with this function. I hope I shall now quickly go and try to show you the solution of this question by using LabVIEW. So let me go there. Now I am here. I go to the optimum optimization by value by LabVIEW, and I go to the example 49, and now we shall have the same solution for the same question by using LabVIEW. Continue to LabVIEW. Here is the graph which I have shown you before. Here is the value, the solution, which is between 1 and 2, it is 1.57. You will see it here somewhere. Now, here it is. The minimum 1.57. And the value of the function at this point is equal to -1. Here it is -1. The solution is the same. The graph is the same. Only how it works. If I go here, really, and show you in detail what I have done. This code here, up to this point, represents how I can generate from LabVIEW an array which is between 0 and 5 and have 100 values. So what I have done, here in this terminal is the iteration element, and this is the output. Here, if I click it, you will see that it runs from 0, it has run from 0 to 1 because I wanted to iterate 400 times. Here, this iteration terminal now is compared with 100. When it reaches 100, this is a comparison function. The output of the comparison function will be true only if the value here is more than or equal to 100. So when I reach the 100, the iteration begins from 0 up to 100, it is 101. And when it comes to 101, this terminal now will stop the program. Now, this is a shift register, a memory element in LabVIEW, and this shift register now is initialized with a value equal to 0. And another value is dot 5. Why this is happening? Because I know I want to have 100 values between 0 and 5. If I find the interval between 0 and 5 and divide it by 100, I will get dot 5. So each value is sequentially will be equal to dot 5. So I begin with dot 5 and add every time, every iteration here, the value, and again add it 400 times. And when it adds 400 times, the program will stop, and I will get at the output here an array, as you see, which contains all the values which I want. So this is the function which is equivalent to len space in Python. I wrote for you here a line as a note. Len space 0 to 5, 100 was created, but it is not required by the print with derivative 1di. If you want to find the minimum without drawings, I mean, you do not need it. But if you want to draw, you need to have the x values. So this is here, the x values are introduced to this for loop and as an x variable to this formula node. It is called formula node. With this formula node, you find y as a sine of x inversed. So x is coming here at the input, y is at the output, and it is inverse. So at the output here, I get instantaneous values of y, and here they are accumulated at the border of the for loop as an array of y's. Now here is y as an array, and now here x is an array. So I bundle them and draw x as a function of y, which is here, which is this function. This is the idea. And the rest of the program here is now familiar to you. You know that this is an initial value. The range is 5. I have taken .75 as intermediate value, just to cope with the example which I did with Python. And here is the formula, minus sine x. Now I give it directly, not concatenated, as I showed you before. Yes, it shouldn't be always concatenated. I have shown you previously just to give you an idea. And now at the output, I get the minimum and the function of the minimum value. The minimum here, as I told you, will be the x value here. And this is the function of the x value, which is -1. Okay, I think this is now clear to you. With this, I finish this lecture. I hope that I have done all my best so that you understand what I have tried to show you. If you want more information or have questions, you can write on the comments and I shall try to correspond with you. Thank you for listening. Wishing you a happy day and goodbye.